guys all have that down right now? Okay, everybody got it? Okay, so again, weather-wise, you know what to do in case the weather does get bad and the Gorgons take control, right? Doesn't it sound like we're in Star Trek right now?
Send out a max.
The Gorgons are coming, Lauren. They're going to take over.
Spell that.
Huh?
Please spell that.
G-O-R-G-O-N.
G-O-R.
This is called Winter Storm Gorgon.
Ours is gonna be
How do
the
they
same.
come up with these names?
I don't know.
I know every other year they do a girl.
They probably take a bunch of Scrabble letters, throw them up, and whatever comes out. They probably get it from, what was the game you guys used to play? The word games?
Words with friends?
Yeah. They give you the letters, and they probably got Gorgon. They probably got 44 points on Gorgon. So they said, you know what, Gorgon's a big letter. So. All right, here we go. Guys, before we left for break, we were talking an awful lot about solving equations. Said there were things that we had to do, like distribute, combine like terms, undo multiplication, division, undo addition, subtraction. Not necessarily in those, or in that order, I should say. But remember talking about stuff like that before we went on break? Okay. Well, today we're going to start looking at is this. Some of these problems are going to involve some fractions as coefficients, and we need to know how to get rid of fractions right here. So what I want to talk about here today is this. 5.6 here is going to start talking about this idea of using a reciprocal. First of all, somebody maybe describe to me what the heck a reciprocal even is. Maybe if I ask this question, maybe this would be a better question. Have a fraction 3/4. Anybody know what the reciprocal of 3/4 is? 4 over 3. You're switching the numerator with the denominator, or the top with the bottom. So as an example right here, if I had, say, 3/4, we think its reciprocal is 4/3, right? And you want to write that down there maybe in that first example. But in the vocab part up there, gang, it says reciprocals are going to be any numbers that are multiplied together to get a product of what? So, to me that says if you have two numbers that are reciprocals of each other, if you multiply them together, you should get what value? 1. Let's check this out. Why is 3/4 and 4/3, why are they reciprocals of each other? Well, let's just take a look at this. What's the operation I'm using right here? If two numbers are reciprocals of each other, then their product is going to be what? 1. Okay, so check it out. 3/4, let's take 3/4 times 4/3. Guys, when we multiply fractions, you multiply the tops with the tops, bottoms with the bottoms. So up top, you have 3 times what here? 3 times what?
4.
Which would be what? 12. On the bottom, 3 times 4, or 4 times 3, if you will. What is it?
12.
12, right? Well, guys, isn't this really the same as 12 divided by 12 right here? If you have one number over the same number, isn't that always going to be 1? So why are 3/4 and 4/3 reciprocals of each other? Well, because when I multiplied the two together, we got 12 over 12, which is the same as what value? 1. These are reciprocals of each other because their product is what value? 1. Okay? Well, let's take a look here then. Next one. Next one here. How about this? What's the reciprocal of 6? First of all, what's 6 even look like in a fraction form?
1 over 6.
Okay, so 6 over 1 is what this is really, right? So its reciprocal would be 1 over what? Okay, check it out. What's 6 times 1 up top? 6. What's 1 times 6 on the bottom? Is 6 over 6 going to get you a value of 1 again? So what's the reciprocal of 6? You would tell me 1/6. How about the reciprocal of 10 then? 1/10, right? Everybody in agreement here? Okay. That's pretty easy, isn't it? Okay. How about then this? How about the reciprocal of maybe 3.5? Uh-oh. Let's see. 3.5 is a mixed number. It's not even a fraction, is it? So probably want to turn that mixed number into, what type of fraction would you turn that into? Improper. How do you turn mixed numbers into impropers, gang? What do you think, Kyle?
Take 2 times 2 plus 1.
So the 2 times the 3, which would be 6, and then 6 plus 1 is 7. So this is really 7 over what? 2. Okay, 3 1/2 as a mixed number would turn into 7 halves as an improper fraction, right? So once I've got that written as an improper right there, what's the reciprocal become? 2/7. First things first, you understand what reciprocals are. Take the numerator and denominator and do what?
Flip it.
Switch them, right? Okay. Secondly, you also know that the product, like this example right here, the product of reciprocals is always equal to what value? 1. By that, listen to my question. 3/5 times 5/3, what is it? 3/5, 5/3. Are they reciprocals of each other? What's its product then? 1. Listen to this one. 3/40 times 40/3. What's it equal? 1. Okay. Cat over dog times dog over cat. 1. Gorgon over Klingon times Klingon over Gorgon. 1. Gorgon. Me like Gorgon. Guys, your toolbox for multiplying fractions. You know what to do, right? Just making sure you know this. If I had something like 2/5 times maybe, I don't know, 2/3 like this. Now, are those reciprocals of each other? Yes or no?
No.
No. So will my answer be 1 this time? No way. Okay. If you were multiplying fractions together, what would you do with the 2 and the 2 up top? Multiply them, which would be 4. This can become 4 over what? 15, right? You guys good there? Okay. This is something that really gets me going right here. Okay. I have kids. If I ask you this question, what's half of 8? Half of 8, 4, right? Okay. But you know what really gets me going? Okay. I start putting a problem down like this. What's 1/2 times 8? And all of a sudden, kids can't do it. Okay. The thing is this. This 8 is really the same as 8 over what? Anytime you have a whole number there, put it over what? So up top, what's 8 times 1? 8 over 2. Isn't this really 8 divided by 2 there, gang? Which is 4. Understand the process? Yes, no, yes? What if I had like the 3 1/2 times maybe, I don't know, 1/10? What's problematic there in that? Can't multiply fractions together if one of them isn't a fraction. How do you make it improper there, Brianna?
3 times 2 plus 1.
Yep, so what's this going to be on the left side?
7.
7 over,
1.
not 1, but
2.
7 over 2 times 1 over 10. Very good. Now can I multiply stuff out? What do you have on the top? 7 and 1. Its product is? 7 over 20. So just some rules right here. Understand, multiply tops with tops, bottoms with bottoms. If you ever have a whole number, put your whole number over 1. If you ever have a mixed number, you need to take that mixed number like we did 3 1/2 and turn it into what kind of a fraction down here? Improper. Okay, now that stuff's going to help us for what it is we're about to do here, but do you understand these rules of fractions right here? You understand what a reciprocal is? You understand the product of reciprocals will always be what value again? Always be 1. You understand these rules down here? If you can understand those rules, you should be good to go. So let's look at page 2. Solving equations using, oh gosh, here's the big word again. Using what? Reciprocals. Okay. Now again, please, please, please don't lose sight of the fact of stuff that we've done in the past. If you ever solve an equation, the first thing you would always have to get rid of if they're there is what? Parentheses. So what property is that again? Distributive. You got to distribute. If there's any terms to combine, you got to do that. Second, is it possible there be variables on the left side and the right side? Thirdly, get your variables on the same side, right? Undo addition, subtraction. Undo multiplication, division. Okay? Now guys, I'll tell you this right here. Solving an equation using reciprocals is going to fall under the last rule. Undoing, this is really undoing multiplication or division. Okay? Using reciprocals really falls under that rule. Undoing multiplication or division. That's really the last step. Okay? So here's how this works. I'm going to kind of zoom up on this and rewrite some stuff so I have a better understanding here. But my first example says, yeah, 5 halves times some number to equal what value? 35. Okay, let's roll on this. You might want a calculator handy for this today. But here's the deal. I'm going to rewrite my whole problem. I'm going to call this 5 over 2 times x equals 35. Now bear with me here, guys. I'm going to write something over here on the left that won't show up on the lesson, and that's fine. Guys, if I had an equation like this, 2x equals, say, maybe 24, what would you do to both sides to solve that? Divide by 2. And when I divide by 2, let's see, left side. Okay, I have a question. I agree that 2's canceled right here. When 2's canceled, this was really 2 divided by 2, right? When I got x alone, how many x's is this really? It's really 1x. This is really the same as saying I want 1x to equal some value, right? In other words, I want this leading coefficient to be what value? 1, right? Well, we just got done saying that if you have a fraction, I can take that fraction times its, what's the word? Times its reciprocal to get a value of what here? 1. So anytime I've got a fractional coefficient, like this 5 halves out front, to get rid of something like that, you have to multiply both sides by its reciprocal. So for solving this right here, guys, if you have 5 halves x out front there, how are you going to get rid of this 5 halves right here? Multiply both sides by 2 over 5. Now check this out. Two things I'm going to do. First of all, this works because of the following. Don't you really have a 2 over a 2 right here? What are they really going to do to each other? They're going to cancel, aren't they? How about this right here? Don't you really have a 5 over a 5 right here? What are they really going to do to each other? They're going to cancel, right? What are you left with on the left side when you have those reciprocals doing that to each other?
X equals 35.
You're going to have x equals 35 times 2/5. Now in our toolbox we said if you ever have a whole number like 35, probably want to put that over what? Okay, so let's do some calculating here. Let's see what we get for a solution. Right over here we've got the x alone, so we've got x equals. Okay, help me up top. What's 35 times 2, gang? 70 over. So we're going to take 70 and divide it by what value? 5. And what's our solution going to be?
14.
It's going to be 14, right? So what's our x value here?
X equals 14.
So 5 halves times 14 would be what value again then? Well, 35. So 70 divided by 5 is my solution here. What'd you get? What do we get there? X equal 14. Okay. How am I going to get rid of that fractional part? You're going to multiply by its. Good. All right, so let's take a look at the second one. Second one's going to get a little bit more difficult. And I'm going to rewrite the problem. I think we should call this 1/4 x plus 2 equal to 3. All right, listen to my questions. Are there any parentheses that we have to distribute for? No. Are there any like terms on the left or the right? No. Do I have variables on both sides? No. And if you don't have those 3 cases, then I got to undo addition or subtraction next. Is there any addition or subtraction to undo? So how am I going to get rid of my plus 2 here first? I'm going to minus a 2 here, and I'm going to minus a 2 here. All agree? Okay, so let's see what we come up with. Got 1/4 x equals 1, right? And this is just like the first problem. Oh, we're back to that situation where I have a fraction and a variable left equal to some value on the right. So to get rid of that fractional coefficient or that fractional value in front of x, going to times by the, which is what here, Brianna? Okay, so what's the reciprocal I'm going to use though?
Oh.
What over what? 4 over 1. So I do that to the left. I'm going to also do that to the right. Okay, let's check it. Stuff that's going to cancel on the left. 4s will cancel. 1s will cancel. What are you left with? 1x, right? And that's what we want for a solution. On the right side, you got 1 times 4 over 1. Probably a good idea to put this 1 over a what? Okay, let's multiply these out. What do you have up top, gang? What do you have on the bottom? This is really 4 divided by 1, which is what value? So solution-wise, how are you going to write that? X equals. This isn't so bad, is it? Pretty much the same stuff. We're just adding another step, aren't we? Adding another step. Okay. Okay, good, good, good. Let's try another one. Oh, I don't like the way this is written. Where do I want my variables to be? In front or behind? I like the variables to be out front of me. I'm going to rewrite this left side. Is that okay? Let's call this a fun. Now, I want you to listen to 2 things in this. In fact, you might want to star this problem. I want you to listen to 2 things. First of all, isn't 3/2 y our variable? 3 over 2y our variable. What sign precedes 3 over 2? That's a negative, right? Do this for me. I'm going to rewrite this as negative. Put your negative with the numerator all the time. Tell us negative 3 over positive 2 times y. So where do I want you to put the negative at all times? Up at the top. What kind of 7 is this really? So what am I going to put behind this? I like it when it's written in this format first. I think you would all agree that we like our variables out front so that we can visualize what to do next. Okay? So solving this, subtract 7. Okay. Let's see what we've got here. 7s will cancel right here, won't they? Right? Yeah. So I've got negative 3 over 2 times y. What's 22 minus 7, gang, on the right? 15. So I'm going to move my work over to here. So we're at the point negative 3 over 2 times y equals what? Negative 3 over 2 times y is equal to what value? 15. Okay, so I'm going to rewrite that. Where's my negative going again? Okay, always move it to the negative. Okay, so help me out quickly, guys. We're at the point where we're going to times by the reciprocal. So what over what? So we're going to multiply by 2 over negative 3. Probably want to put the 15 over what again? Yeah, if it's not a fraction, put it over 1. And we're going to do the same thing to that. Multiply by 2 over, I'll squeeze it in here, negative 3. There we go. 2's are gone. Negative 3's are gone. And that's what we want. We want y to be alone, don't we? Isn't that what we're setting out to do? And up top, help me, 15 times 2. On the bottom, how about 1 times negative 3? So my solution, we're saying, you know what, let's take 30 and divide by negative 3 and see where that puts you. What kind of 10? Be negative 10, right? Okay, so your value here is negative 10. Whoa! That looks like a 10 in a can. I want that. Negative 10. So all right, y equals negative 10. Now guys, please, please, please don't do this to me, all right? A lot of times I see stuff like this. It's like, oh, here's a concept. There's fractions out front. We're going to multiply by the reciprocal. Yeah. Okay, did you get the book page written down? Okay. Hey, guys, is there a fraction out there in the front of this one? Any fractions in this? No. Do I have to use a reciprocal then? The only time you use a reciprocal is if there's a what in it. Okay, why can't, who's to stop me and say, can't I just divide this by negative 6 right off the bat, guys? I could, couldn't I? Okay, and then you're done. All right? So don't get caught on this, oh, we're doing this, 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 this. Don't get caught in the idea that, oh, well, since we're talking about fractions today, that means that's the only thing we're talking about. Don't lose sight of the stuff that we've done in the past. Just divide both sides by negative 6 here, right? Right? Okay, so don't lose sight of that. By the way, what would that be? Negative 20 divided by negative 6. What do you get when you punch that in? You get 3.3 repeating? Yeah. Okay, so don't lose sight of that, all right? Okay, questions on that page at all, first of all? questions? Oh, we've got more to do. Never mind. We're not done. We're not done. Let's do some more. Actually, you know what? Let me see what the next page looks like. All right, you guys try the next two on your own. Go ahead and try those two. These two right here. Negative 3/4 x plus 2 equals 8. And then 8/5 d. Maybe I should rewrite them for you. So this one right here, I want, and I'm gonna have some volunteers come up here and do this one. Hey, do you want to keep this one the way it is also? Yes or no? Is the d out front with its coefficient? It is, so that's good, right? I don't like this problem. This is a typo right here, gang. So change this -1/6 for me to -16, would you? Change that. It should be a -16, not -1/6. Guys good there? All right, go ahead and give those a shot. I'm going to go to the App Store and get some Gorgon fighters.
What is it reading? Have you looked at the radar?
I know how to defeat Gorgons.
Have you looked at the radar lately?
Nah. You know what radar spells? I look at it backwards though. I look at radar backwards.
My dog named it Radar.
Still spells radar. Wow.
Oh, wow.
Wow.
My dog named it Radar.
I just said all backwards.
Yeah.
You didn't even catch it.
Yeah, I did.
Well,
No, it's not.
it is.
Radar.
What do they call that? Something.
Dog race.
What do they call it? What's a word that's spelled like level? The word level. Race car. Bob. Pop.
Hey, which one is it?
LOL.
It's not a real word
It's
though.
not a real word.
Isn't it in Wikipedia?
Well, then it'd be loud out loud.
Loud out loud.
What?
Still LOL.
But the actual words don't spell.
Oh, but the letters spell LOL.
Oh.
How about SOS? Smiling is my favorite. Yeah. What? Did you get an answer? Okay, see it. You guys know on that last one, it's a typo. It should be -16, correct? I like the last one. I'm not sure about the first. I like the top one. I think I like the bottom one. All right, let's check these out. I'm not going to talk through these, but could I get a volunteer to maybe share their thoughts on the first one for me? Somebody want to talk to me? Megan, go ahead. Tell me what to do. Subtract 2, you said? Okay. So I do that here and here. All right, so tell me what you have on the left and the right side.
-3/4 x equals 6.
Okay. All right, so yeah, I'd buy it. How many agree with her so far? All right, let's roll.
And you want to do the reciprocal of -3/4.
So what over what on the left?
3.
What kind of 3?
-3.
Probably want to do what on the right then?
-3.
Okay, anything that sticks out that might be problematic for you that you might want to adjust? Yeah, put that 6 over a 1. Okay, let's work on the left side. Tell me what's going to happen on the left side. Goodbye, goodbye. So we're left with x, right?
Yeah, and then 6 times 4 is 24.
24 up
And
top.
then 3 times 1 is
So those two would be -3.
yeah.
So how about the quotient of 24 and -3? Where's that put you? X equals -8. Okay. Megan, that was excellent. Thank you. That looks like Peppa Pig.
It looks like a goldfish.
They do. Hey, if goldfish had numbers on them, why would you buy them? It's pretty cool. I'd put them in a tank. I'd put them in a circular tank and watch them race.
There's glow in the dark ones.
Huh?
There's glow in the dark fish.
Are there really?
Yeah, if you put like a blue light over it, they like glow.
I have them.
Are they like tetras or something like that, or are they some kind of saltwater fish?
It's like fresh fish.
Cool.
I saw one at Walmart.
Brianna, you want the next one?
Yeah.
Okay.
Subtract 4.
All right, hang on one second. Everybody listen up quick here.
Subtract 4.
Subtract 4, right?
Or
Add 4.
That's right.
I'm sorry. Caught me.
And then it's negative 12. Negative.
Okay, so tell me what you're going to have on the left side first, Brianna.
8 over 5d minus negative 12.
All right. All right, so rock and roll.
And then multiply by their goal, which is 5.
So we're going to times by 5/8. Again, 12's a whole number. I'm sorry, -12's a whole number, so I better put that over A.
1. And then the left side cancels out.
Yep. So I've got the 5's gone and the 8's gone. So we've got B equals
And then it's negative 60 over 8.
-60 divided by 8. And when you hit that in, what'd you get?
Negative 7.
I'm at -7.5 for that. Okay. Now, guys, honestly, it's pretty easy, right? Okay. Now, the next part I said in this situation was, you know what? First part's pretty easy. Second part's going to be kind of difficult, right? Okay. So what I want to show you is this. Let me write the solution to this down first. We got out of this situation that -60 divided by 8 was -7.5. You said, Bree?
Yep.
Okay, just out of curiosity, you guys okay with these two right here? Here and here? Are we good? Everybody okay with those?
Yeah.
Questions to this point? Okay, this is where things are going to get goofy. And I don't want you to make this harder than it has to be. I think if you just pay attention to what I tell you to do, you'll be in very good shape. If you don't pay attention to you, this will look like Chinese. Okay? Example 2 starts talking about solving for an indicated variable. Guys, in all the problems that we had prior to where we're at right now, we had just an x in here, okay? Right? We'll take a look at these examples right here. So solve for an indicated variable when there are, how many variables? 2. Dirty, 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 dirty people. Math. Crazy people. But it is the only subject that counts, right?
Yeah. Except for our science.
That was a joke. Only subject that counts, math. Solve for each indicated variable. I want you to listen carefully to this. Here's how I'm going to do this. Okay? Whoops, I didn't want to do that. I wanted to do that. Guys, look at my first example up top here. It says solve for each indicated variable. You have 4x minus what? 2y equals what? 18. What variable does it say we're solving for? When I tell you you're solving for y, that means you have to get y all alone. So we have to have y equals something over here. You might have y equals some mess over here. But as long as I get that y value all by itself, you are done. Okay? And I'm not going to make this any more difficult than it has to be. One thing I would tell you to do is not look in the back of the book for solutions to this, because your answers in the back aren't going to match what you have today. And I will know, well, I know it's something to do, all right? But
Honestly, I don't know.
just don't do that, all right? Because you're going to have some things that look different compared to what they're going to have back there if you're checking yourself, okay? All right, here's the deal. Right here, I have an X and a Y on the same side, right? Okay, here's how you do this. It says solve for Y, get Y alone. All right, here's the deal. If I want Y to be alone and Y is on the same side of X, it might be a good idea to get what letter away from it first. Get the X out of it. Well, how many X's do you have here, gang? 4X, don't you? Okay, what kind of 4X is this? Let's move X out of this, okay? Get X away from Y first, okay? Get X away from Y first, because we're trying to get Y to be alone. So watch what happens here. I'm going to move this out. I'm going to rewrite the whole problem. Okay, you said it's a positive 4X, right? So if I wanted to remove a positive 4X from this side to start working on getting Y alone, you got to subtract that out, okay? Now watch what happens here. Guys, first of all, on the left side, the 4X's are like terms. One's positive, one's negative. So what are they going to do to each other? They're going to cancel. They're gone. What are you left with on the left-hand side? Keep in mind, what are we trying to get alone first?
Y.
In order to get Y alone, I have to have negative 2Y alone first, right? Okay. Well, what's this going to equal on the right? Are 18 and 4X like terms? So the only way I can express that is as 18 minus what? 18 minus 4X. Okay, now, what would you do to both sides? Divide by what? What kind of 2? So I divide the whole left side by negative 2. You're going to divide the whole right side by negative 2, right? What are the negative 2's going to do here and here on the left? Okay. Hey, I got a question. What variable am I trying to get alone?
Y.
When these cancel, is Y all alone?
Yeah.
What's it say Y is equal to?
18 minus 4.
All over what? Once you get that Y alone right here, your mess of an answer is right there. Okay? We said we want to get Y alone, right? In order to get Y alone, we had to get negative 2Y alone first, which meant get that 4X out of there, right? But the 4X, does this 4X combine with a constant of 18? The answer is nope, it doesn't. Okay? No big deal. Write it as 18 minus 4X. Follow your steps. Again, have I gotten Y alone to this point? What's Y going to equal then? Well, 18 minus what? 4X minus what? Well, minus 2. Let's try another one. What am I trying to solve for in this one? Okay. Might be to your benefit, especially when you get the practice here, is circle what you're trying to get alone. I'm going to circle the X. I'm trying to get X alone. Okay? If I want X alone, probably better get 3X alone first, right? So let's see. 3X is paired up with a plus 6Y. So in this part right here, when I have 3X plus 6Y equals 10, well, I want just the X to be alone. So I better get 3X all alone here. So I got to get that 6Y out of there. How are you going to get rid of a plus 6Y? You're going to subtract your 6Y, right? What the 6Y is going to do to each other? Right? Divide everything by what now? Threes will do what here? They're gone. I wanted to get X alone. Is X all alone?
Yeah.
So what's its mess of an answer going to look like? 10 minus 6Y all over what? 3. Okay. Guys, you get messy answers when we have how many variables here? You're going to get messy answers when you have 2 variables, right? We got good, nice whole number answers when we had just 1 variable on the first page, right? You understand what's going on here? Let's see, is there another example to try? Or is there two more?
There's two more.
Let's look at, ooh! Hoo-hoo-hoo! Oh my gosh.
It gets better.
Wow. These guys. Let's, this is totally a mistake, and that's okay. Let's rewrite this. This should say solve for y if you have 3/4 x minus 1/4 y equals 12. Put an equals 12 there, gang. Oh, this is ugly.
I don't like this.
It's ugly. Ugly, ugly. What am I trying to get alone?
Why?
I want y alone. So what do we better get out of there first? Anything with an x in it, right? Well, I got to do 3/4 x, right? Be careful on this one. Okay? This is a positive 3/4 x, just like it would be a positive 7x, right? If I was getting rid of a positive 7x, subtract 7x, right? This is a positive 3/4 x, just like a positive 7x. You have to subtract to move the x's. Subtract a 3/4 x from both sides. Okay. What's a positive 3/4 x, or this is really like 0.75x, minus 0.75x going to do to each other? What are they going to do? Cancel, right? La, la, la. So we've got -1. Where am I going to put the negative at with this fraction? Up top or in the bottom now? At the top, I've got -1/4 y. Watch what this equals. 12 minus what? Okay, everybody follow me so far? Now, this is the part right here. We had like a positive 3y, we would have divided by 3. But this is a case where I've got a fraction in front. And we need to undo multiplication of a fraction. So we're going to multiply by the... Now, guys, up top here, when we did the division up here, to indicate that I was dividing everything by like a -2, I put a line all the way around it. This is like saying all of this mess up here in parentheses divided by -2. Or up here in this example, all of this mess, 10 minus 6y in parentheses, all divided by what? In this example, 3. Well, down here in this situation, to indicate that I'm multiplying by a reciprocal, to indicate I'm multiplying everything right here by that reciprocal, you're probably going to want to put that in what? Parentheses. Right? So we're going to multiply both sides by 4 over what? Well, 4 over -1. What is 4 divided by -1, by the way? All right, right here to this point. You understand why the -1/4 y is alone right now, right? And you understand why I'm multiplying by the reciprocal now? Because we're trying to solve for which variable? Okay, aren't these all going to cancel right here? So y is going to equal. All right, I'm going to move this out front. What's 4 divided by -1 right here, really? Okay, this is 4 over -1. It's really what value? -4, isn't it? 4 divided by -1 is -4. Isn't this really -4 times that mess of... Isn't that really what it is right there? Is y all alone to that point? Huh? Well, you could. You could get rid of parentheses. You could distribute. It would be 48 minus 3x, but I'm not going to go that far. You guys okay with that? It's a tricky one. If you're solving for one variable, get the other one to the other side first, right? So let's try one more example here. You guys have this down right here? Let me know when you've got it. We'll talk our way through the next one together. All right, let's try this last one here. There's only one left, right? Okay, I'm going to rewrite this problem real quickly. Whoa, where did it go? The Gorgon's got it. The Gorgon's got it. Oh, there it is. Take me to your heater. am I trying to get alone here? Trying to get x alone. So if I'm trying to get x alone, I better move the y to the other side. What kind of y do you have? Positive. So to get rid of a positive y, we have to subtract. So I'm going to subtract how many y from both sides?
5.
You guys agree with my first step? Agree with the first step? So I'm going to have 5 over 9x equal to the mess, and I'm going to put in parentheses right away, equal to, won't it be 2 minus 5 over 6y, guys? You can go ahead and put in parentheses right away like that. If you can't combine like terms, just put it in parentheses. Okay. Now, my coefficient for x, is it a whole number or is it a fraction? Fraction. So to get rid of that fraction out front, to leave x out there, you're going to times both sides by what? Times by 9 over 5 here. Times by 9 over 5 here. Okay. What are the reciprocals really doing to each other? 9s are gone, 5s are gone. Is x all alone? What's x equal to then? Well, it's equal to that mess. 9/5 times the quantity of 2 minus 5/6 y. Basically, your job in that, when you have two variables, move the first variable that you don't want to the other side, right? Once you move that variable to the other side, I'd probably put it in what right away? Parentheses. Then you're either dividing or multiplying by a reciprocal. Anybody need to see anything up there again quickly before I shut this down? Anybody? Okay, book page wise. We all get that at the beginning of the hour? Okay, just understand that if we do lose a day because of weather, push it back appropriately. All right? So what I would strongly suggest is this. Get a look at that stuff tonight because I expect questions over this tomorrow. Okay? So come prepared. If there's something you're not sure of, come with questions if you're not sure of something tomorrow. All right. The quick quiz, if you want to peel that off there, go ahead and peel that quick quiz off.